Hey, glad you can make it. This video will show how we can use column names for the Google query function. The link to the completed model, which will be shared as viewer, is in the description below, along with links to other resources I will mention during this video. So this is the model I'll be sharing, the completed model, and we'll go ahead and develop this model in just this scratch sheet that I have over here. So if you're watching this video, you should have experience using the Google Sheets query function. The second argument of query is where we select what we want to see along with other optional clauses to filter, sort, group data, just to name a few. In most SQL implementations, one would specify the column names of the table in the select clause of the query. The query uses column references, though, such as column A, B, C, etc. Now, if the data is coming from an array, perhaps from the results of an import range function, query uses notation such as column 1, COL1, column 2, column 3, etc. to reference the columns in the table that was sent in the array. All right, so I'm going to grab some data. Let's open up a new sheet here. And we'll just grab some data from the example I'll be sharing with you. And I'll just copy that data into this fresh spreadsheet. Alrighty, so an example how we would do a query on this data using the standard notation would be just equals query, and then we reference the range of the data. So in this case, it's going to be A1 through G. I'm going to leave off the second number of rows, so it just selects all. And then we do say select and which columns we want. So I want sales rep, I want the item D, and I want the total sales, that's G, and we want this for any sales greater than 250, and we'll put a 1 for one row of headers. So that's a standard query, works fine, one of the most powerful functions in Google Sheets. But there are some disadvantages to using column names, and I'm sure that most would agree. Number one, that seeing the select clause using column names instead of letters would be more intuitive than using references to columns. So as you can see, that is definitely something we want to strive for. So an example of how this may look would be something like this that I have pasted in a notepad. So instead of selecting by column, we're using the names on the table. Sales rep, item, sales, where sales is greater than 250. Most people would be hard to argue that that's not pretty obvious as opposed to the letters. So another reason, which, I mean, you can get used to that, of course, I did. Many of us can adapt to just about anything, but another reason that it becomes much more important is that if your column change, you insert a column or something like that. Let's say you want to start tracking the item ID, and if we insert a column here, item ID, all of a sudden items over here, things aren't working correct because the column C is the sales rep, and column D is the item, but now we inserted another column, so column G is no longer the sales, it's now the unit cost. So it throws things off. Let's undo a couple of times, and it's right back to where it was. Okay, so that breaks it, but you know, we've all know about this shortcoming and being able to work with that. And we understand that the select clause is a string. So when we update formula, when we move things around, insert rows, columns, move cells, Google Sheets will update the formulas for you with the correct cell references. But if it's a string, it doesn't understand that has to go inside your string and change things. So that's the now fault of Google Sheets. So one day I stumbled on a YouTube video of a way to use column names for the query function. I've included a link to this video in the description below as well. And here is an example of his implementation, which I've also included in the working model I'm sharing. So we'll just go over to the query by name, and there's a tab there called MYSELECT. And there's the label here is as the formula that's here, contained here. And he uses the query command and then takes your data and puts it as an array by putting the curly brackets. And then he calls his custom function MySelect with very similar syntax that I showed you before, but he encloses the column names in square brackets, which I think makes sense. So sales rep, item, sales, where sales greater than 250, and there's the range and the number of rows. So there it is in that version there. And his custom function seems to work consistently well. I've written many custom functions myself, and they can be quite useful. Some of the ones I've written that are very complicated, though, seem sometimes for some reason they just stall out and have to be kick-started. But this one is fairly tight, so I've never had an issue with his. But some may not prefer to use AppScript, and that's what custom functions use. AppScript is based on JavaScript, and I'll show you a quick glimpse of his custom function. We'll just go to extensions and AppScript. And there it is. Not a lot of code there. Very tight JavaScript. As I'm kind of a JavaScript hacker. By that I mean I've written quite a bit of JavaScript, usually just by searching for what I need at the time and adapting it into the project I'm working on. I would like to consider myself maybe a moderate experience level in JavaScript. The guy in this video, though, he's on another planet, and based on where my experience lies anyway, I would likely need to watch this video about 20, 30 times to fully understand the clever JavaScript he uses. The link to his video is in the script as well as in the description below. So there's the link to his YouTube video right here in the script. And I learned quite a bit from this video. Debugging custom functions can be challenging, to say the least. If any of you have ever written any, you'll know what I'm talking about. But he uses the browser's built-in inspector, which I would never even thought to do that. So kind of had an epiphany of sorts. So kudos to this guy, and there's a lot that you can learn from him. So his video doesn't include a link to the shared sheet to grab his script. I believe I was able to follow along, and have included this MySelect custom function in the same sheet that I'll be sharing below. You can make a copy, and when you make a copy, you can view and even change the app script, and I encourage you to do that. So I was determined to achieve the same goal of using column names for the query function, but using built-in Google Sheet functions, native Google Sheet functions, no app script. Now, Google recently released a suite of powerful functions that work with arrays. So this is naturally where I started looking. My first thought was to use the map function. I made a bit of progress and hit a brick wall. And I started turning my attention to the make array function. I got a few steps further with that, but hit another wall. So after banging my head against the wall for many, many hours, I set the project aside for a while. And one Monday, I got my weekly tip email from Ben Collins. If you don't know, Ben is a Google Sheets guru. And signing up for his website is free. There's lots of free information there and resources. And he'll also send you weekly tips delivered directly to your inbox as well. The free information he offers is humongous, and he also offers paid resources. I've included links to his site in the description below. Well, one of the weeks of Ben's weekly tips was showing the scan function. And something about it just seemed to click that this just might be what I needed for completing my project for the native sheet functions to be able to use column names in the query function. I struggled with this one as well. And during the entire project, I just couldn't stop wishing that Google Sheets doesn't introduce a for function, as this no doubt would be how one would want to handle to achieve the objective, just like they would do in some traditional development language like a JavaScript. Well, to achieve our goal, all that we really need to do is to take the range argument that is passed the query and convert it to an array, just like the fellow did in his model, and adding curly braces to it. And then if we take that select string, clause, I guess, if you want to call it that, all we have to do is search that string for the column names and replace them with the appropriate COL number references, column 1, column 2, column 3, which is what we use, if you remember, when we're searching array elements versus column elements. So I'm following the same approach. Before I get to that, let me how do we go about doing these substitutions? That's really the challenge, I guess. And the MYSELECT author uses regular expressions in his custom function. In my mind, regular expressions are extremely powerful, albeit they're not really super intuitive and often sometimes very complex, especially if you're new to regex. I'm following the same approach as the MYSELECT author as far as how to specify the column names. He puts them in square brackets, and this makes it easier to swap strings that may be similar, such as in our example. As you can see, we got two columns both with the word sales in it, sales rep and sales. So when we have it in square brackets, then it's eliminates substitution mistakes, shall we say. So here's an example of the sample select clause that we may use in our example. I have that in a notepad over here. So select, and then with square brackets, sales rep item sales, where sales is greater than 250. Pretty intuitive, wouldn't you say? I knew the sheet's formulas were going to be complex, and that I would create a named function wrapper around it to make it simpler to use. Named functions was another Google Sheet recent release, shortly after the array functions they released previously. Named functions are amazing. If you have not used them yet, I highly suggest you check them out. Ben has free information on named functions on his site, and I have linked that below in the description as well. I also have a name function 101 tutorial, which I linked in the description as well. I maintain a sheet, which is in a sense a library of name functions, and I've included the name functions used for this video in that library, as well as in the working QueryByName working model that I'm shared below in the description. So just think of the library as a central repository of all your name functions. And when a project requires one, we can simply import the name function into your current project. As great as name functions are, there is some room for improvement, and my video goes into detail on how Google can improve name functions as well. I decided to call my name function QueryByName. Disclaimer, the approach I developed uses the column function, which only works with ranges, not arrays. So if you were directly importing data into the query function using import range function, then the QueryByName name function would fail. However, you can easily do the same thing by just creating a sheet in there in your spreadsheet, and in there, that sheet, just have your import range there, and then have the query by name function reference that sheet, and then it would work just as fine because that is in the same spreadsheet, and you could reference it using column A, B, C, etc. All right, so the first argument is the data. The second argument of the query by name name function is the range of column names. So in this example, that would be A1 through G1. And the third argument of the query by name name function is going to be the data range. So in this example, it's going to be A1 through G. And yeah, you could specify the through 44, but as you add rows, it wouldn't be included. So most people will end up using just the A1 through G and leave out the row number, and it will grab as many rows as there is data. Alrighty, I'm going to just create another sheet here, and just kind of like a scratch area, and I'm just going to grab the column headings, A through G. You'll see the method to my madness in a moment. Alrighty, so now just get the data out of the way, just so we can focus on, in the beginning, all we're going to really need to worry about is the column names, or the field names. All right, so name functions can call other name functions. So instead of making one huge name function, I would break it down with at least one or more helper functions. So in this case, I envisioned that we'd be working with an array with as many columns as there are in the table, with at least two rows, or two elements in that array. The first row or element would simply take the range of the column headings and add the square brackets onto each side, so we can match them up against the select string that we were using before with the square brackets. And we can use the map function for this. So we can just write equals map, and in this case it's A1 through G is our range, and then Lambda does the work for us. And in this case, we want to take the string. Each one of those one by one, order date, region, sales rep, etc. will be the string, and then using concatenation, put square brackets around it. Nothing special here. The ampersand is one of the ways to concatenate. You can use concatenate function if you prefer, but we'll just use that. It's shorter. And then another concatenate, and then a right bracket, quote, and two parentheses, I believe. All right, so that basically takes this string up here and replaces it with the same names, just with square brackets on each side. All right, so let's build the second row. The second row should be the column number substitute for each column name that we're going to need. So in this case, we'll stay with the map again, and same range, so that'll be A1 through G1, and Lambda will take the string. You can call whatever you want here for the variables. It really doesn't matter, but I just would always recommend staying away from any internal functions, which could confuse sometimes Google Sheets. Since we're dealing with columns here, I'm just going to say col for columns, and then we're going to build the string with concatenation and the word col, close quote, again ampersand to concatenate, and then we'll use the column function for each of the columns and concatenate. Oh, we don't need anything else after that, so we'll just then close it out with 2 more parentheses, and that should do it. All right, so this will be element 1 in the array, this will be element 2 in the array. So when we're all said and done, we're going to go find that string, the select string, and substitute any references to those text labels with the numbers. So col 1, 2, 3, 4, 5, 6, 7, etc. All right, now I decided to use the substitute function in my QueryByName function. I could just have easily used the reg replace function, which is part of regular expressions, as the author of the MYSELECT function chose to do. Now, regular expressions do use special characters for certain pattern matches, and therefore those must be escaped out if they in the string if they appear. So in this case, they do use square brackets, so we would need to escape them out. So back to the map function, and same range A1 through G1, and lambda, and we'll use string for the variable holds placeholder in this case, and start building our string. So that would be the backslash for the escape character, and then the square bracket, and then we'll concatenate that with the string that's being passed, and then concatenate that with another escape character backslash and the square bracket, and then 2 parentheses. All right, so my QueryByName isn't going to be using this 3rd row, but I figured I'd include it in case somebody decided to not use substitute and to use the reg replace instead. Alrighty, so we can put all these together, all 3 of these functions together, and let's just use Notepad as a temporary holding place here, into one function. So we'll start by grabbing this one and pop it over to my Notepad, and we'll put curly brackets here to start. And then the next one is going to be this formula. We don't need the equal sign this time. And we're going to separate this with a semicolon, so it'll give us a new row. And then the last one will be this 3rd formula without the equal sign. And another semicolon, and then a curly bracket. Let's see if this works, if I got it right. I often use Notepad to build formulas like this when I'm copying from existing formulas. All right, and sure enough it does. So that one formula returns an array of 3 rows by 7, 1, 2, 3, 4, 5, 6, 7 columns. And we'll be using that as we move forward. All right, so this is a somewhat complex formula. So I decided to wrap it inside of a name function, and I'm going to be calling this query name helper. It doesn't matter really what the name is, and it probably would never be used on its own by itself. So let me go ahead and do that. So we go to data, and then name functions, and we'll just add a new function, and we'll call it query name helper. You don't need, there's a lot of optional stuff here. Is anything that's marked optional, you don't need to put in, but I'll put it in for completeness sake. In this case, the argument we're going to use is something we'll call range. And I believe that's the only argument we'll need. And the formula definition is going to be the same that we had over here, except that we'll be swapping out the literals for the actual function. So let me grab that from the notepad that we had, and we'll put that in here. And all we got to do now is take out any place where we reference the range, like A1, G1, with the variable range. So it should appear in 3 spots. Alrighty, if we don't make a mistake, we'll move forward. And we get to add a description for the range. Again, it could be left out, but the more you put in, the more easy it becomes to use. And then an example, so I'll just write A1 through G1 and then create. All right, so now you can see that we have this kind of complicated function here, formula here, I should say. And that now can be referenced just by saying equals query name helper, and then pass it A1 through G1. So we get the same results as we got above, but without typing all that difficult syntax, which is easy to make a mistake. Trust me, I've made lots of mistakes during the development of this, and hunting down missing parentheses and commas and stuff like that could drive you crazy. So, you know, it's a lot simpler and less error prone. The sheet I'm sharing with you has the name functions in it. Creating them is really beyond the scope of this video, but as I mentioned, I do have that deep dive video into name functions linked below in the description. Google Sheets handles arrays really well and allows us to do sophisticated manipulation with them. And arrays are a common type in most development languages and may be intimidating if you have never coded before. However, I'm sure most of you have some sort of table like our sales table, and that is not really an array anyway, as it is composed of rows and columns. All right, so we'll go ahead and get started by building our scan function. The scan functions can be the basis of the QueryByName function, and it takes 3 arguments. If we stop typing scan here, we can see what those arguments are: an initial value, an array, or range, and then the lambda itself. And the initial value in this case is going to be the select clause. In this case, that's going to be, well, in this case, it's going to be what we've been working with. So I'll just paste that right in here. So something like that. It's like sales rep, item, sales, where sales is greater than 250. And then we can use the onion approach and start building the function from the inside out. So we'll start off by writing the substitute function. So if we equals substitute, and then what are we going to substitute? In this case, it's going to be this select string, and I'm going to make that absolute because we're going to be copying this formula. And then what do we want to substitute? We want to search for this field name with the square brackets and replace it with the column number representative. And that's it. We close the parentheses, and then we can copy this formula across to column G. And we can size the column so it's easier to see, or just for viewing purposes, we can use the transpose function to switch it from horizontal to vertical. So we'll just transpose that. Through G. All right, there we go. All right, so I'll select string references 3 columns, sales rep, item, and sales. So the first two formulas that we see here on unchanged, as those columns aren't reflected, but we can see that column 3 gets substituted out for the sales rep, and then column 4 for the item, and then sales for column 7. All right, so now let's work this so that substitute is working off of a set of specific cells like we were in our formulas. Well, let's create the raw formulas, and then we'll build on that from there. So the index function is kind of useful. If you haven't used it, it works with arrays great. So in this case, we'll start off by index, and then we'll use our query name helper function that we created earlier, and reference A1 through G1. We'll make that absolute because I'm going to be copying that in a minute. And we want the first row and the first column. And I made a mistake, so query naming. Okay, yep, got the wrong parenthesis in the wrong place. We'll put that there and get rid of the one at the end. All right, so that's order date. Let's copy that down 6 more times. And then just change the last value to column 2, column 3, column 4, 5, 6, and 7. All right. Now let's do the same thing, except instead of first row, let's grab the value from the second row. And we'll just copy those formulas down and just make a small change to reference row 2. And we should end up with just column 1 through 7. When all said and done. A few more to go. Last column. All right, so we're going to be substituting these values for these values. Alrighty, so we can put this all together now in a scan function to make our life a little easier. I'm going to take the formulas we put above and just paste them in Notepad temporarily. And this one as well. Okay. Now we can start by building the scan function, which takes 3 parameters. So it's equals scan, and we want to scan our select string. I forget where we put it. Let's go find it. There it is, up in A19. The second parameter is going to be the column headings. In this case, A1 through G1. I'm also going to make it a absolute reference as well. In fact, I didn't make the first one absolute. Let's make that absolute. And then the last parameter is going to be the lambda. And we'll have a string and a current value. And the first one will be the substitute for the first one. So that's going to be this guy. So let's see if we get this right. Substitute. And then string, and then that formula we just copied. And I believe 1 comma, we already got the 1 comma 1. All right, good. And then we need to do a similar lookup for the second one. So let's grab that from the notepad, second row. And then I think we need a few more parentheses. And keep our fingers crossed. Double check, string, range, lambda, substitute, and enter. Ooh, rare that works on the first go. Alrighty, so not a bad start, but right now the formula is hard coding column 1 for everything, so we need to add a formula so that it adjusts for each column. I'll go ahead and copy this formula down, and we'll edit it and replace the hard-coded column 1 with a function for the column. And this will take QueryByName. And one more time, let's open up our formula bar a little bit. It's fighting me. There we go, I think. Column QueryByName. There we go. All right. Alrighty, so if we put our cursor in column G, you'll see it made all the substitutions for us. So column 3, 4, 7, where 7 is greater than 250. Alright, let's copy this formula down one more time and use the index function to return just the last element in our return array. So we can wrap the entire function with the index function. And we'll want the first row. There's only one row returned, but we'll have to specify it anyway. And we could write 7 for now, and that returns the last one. But 7 is hard coding because we happen to know there's 7 columns. So we won't want to do that, of course. So we'll take that 7 out, and we'll replace that with the columns function. The columns function will tell us how many columns are in a range. And we'll write A1 through G1. Make that, in case we copy it again, we'll make that absolute as well. And I think that's it. And there's the last element of the array. Whew, that's some formula, huh? All right, so let's go ahead and build our QueryByName named function, which is going to use the basics of what we just built, and the name function is going to make it a lot easier to implement and far less error prone. So I'll go ahead and grab this formula and copy it to my notepad. We'll come back to that in a moment. Alrighty, so and we'll go ahead and add a new name function, data, name functions, add a new function. We're going to call it QueryByName. description. This allows using the field names in a query. This one is going to take 3 parameters. It's going to take the SQL string. It's going to take the headers. And it's also going to take the data range. And for the definition, we'll start off with the query function. And this will take the data range, but we're going to convert that to an array. So we'll put some curly brackets, and then we'll use data range. And then we can now use the function we just wrote before with the index. Oops. Wrong paste. I'll just grab that from the notepad. All right, and I get the index of that. And I think that we got everything we need. That doesn't seem to right now. We still have something missing here. Oh, close parenthesis for. We also need the specified number of header rows for a query, which is 1, and then a right parenthesis. All right, that goes fine. Oh, we got to now substitute. So the A1 through A19 is going to be the SQL. And that's going to be the headers. And this is also going to be headers, wherever it says A1 to G1. I think one more and we're done. It'll let us know if we made a mistake. But I think we got them all substituted for the variables. We got SQL, headers, and data range, and next. All right, so we put it in a description for our first argument, SQL. And again, it's optional, but we'll just put something in, and then it wants an example. So we'll just put the example we've been using. We're going to use that again in a moment. And then an example for headers, description for headers, and example for headers. And let's say A1 through G1. And data range is going to be the range of the data to be queried. And an example could just be A1 through G. And create. All right, now let's have a drum roll and we'll see if it works. So let's go back to our data over here. And I guess we don't really need this standard one, so let's get rid of this. All right, so let's go ahead and get rid of the first query that we did the standard way. And let's build a new function with using the QueryByName function. So QueryByName, and we'll put in the SQL. It could be any query you want, but we'll go with that one, what we've been using. In this case, the headers is going to be A1 through G1. And the data range is A1 through G. And that should be all we need. And sure enough, there she goes. It works. There we go. QueryByName. Alrighty, so I was thinking what would happen if the table did not start in the first column A. The column function we are using would probably be thrown off because it will be returning some numbers other than 1, 2, 3. So it wouldn't work as we would expect, and we can see that if we just insert a column before A here, and all of a sudden we get this reference error because it's looking for numbers up to 7 and it got an 8. So let's clear out that column. So my first thought was, well, you know, if we wanted to, we could just state that in the function QueryByName function that it requires the data to be in the first column, or we could choose to adjust for that by calculating an offset number. So it wasn't that difficult, so I decided to go to Lambda to make the QueryByName function more useful. So we'll start by copying this data set down and to the right. Let's say row 50, and I'll start over here at column H. And let me go grab that formula we wrote for QueryByName and copy that formula, and we'll copy that down, and this time it'll be in put in column A 50, and we'll adjust for we're going from H to N, so that'll be an N, and this will be an H, and this will be an N, and this will be an H. Oh, we also need 50, row 50, and the 50 on the other one as well. I think I got it right. To double check, HN, H1, there we go. That should be H50 to end, and that should work. Well, not totally work, but at least get us the same kind of error that we had before. All right, so now how do we fix this? Well, we could start working on building this index, well, the offset formula. So we'll use the column function for that. If we use column for cell H50, we should get 8. Okay, that's as expected. Now, the column function takes a single cell. Our named QueryByName function takes a range. So with the help of the index function, we can extract just the first value of that range that we'll be passing. So we'll take the column, just take this function we just wrote, and we'll add index into it as well. So index H50 through N50. And we want the first row, and there's only one returned anyway in the first element, and I think one extra parenthesis, and we should get the same number. Great. Alrighty. So if the table starts in the first column, the offset should be 0, and if it's not, then it will be whatever column that's in -1. So in the case of column 8, so if we're in column 8, -1 would be 7. So the offset will be 7. So in this data set, H would be offset by 7. So it will be 8 minus 7, and that would give us column 1. And then in column I, it will be 9 minus 7, which is give us 2, 3, 4, 5. Exactly what we want. All right, so let's go ahead and write this as an if function. So we can say if all that jazz, I'm going to copy that, is equal to 1, then the offset should be 0. Otherwise, it should be whatever that column is, -1. And I think I got all my parentheses right. All right. So there's our offset at 7, and not the most complicated formula in the world, but certainly a bit more than I think we want to type. So to make it a little bit simpler, let's make this a name function. So I just copied that function, and we'll come over here now, and well, it doesn't matter where we are. We'll just go to data and name functions and create a new one. I'm going to call this guy query offset. And for the description, it's optional, but I'll fill it in anyway. And it's going to take one argument, which is going to be a range of headers to match the argument we have for our query by name. Not that it matters, for this is a totally different name function. We'll call headers, or header range, or range header. Let's just write headers. And the definition is going to be what we wrote before. I'll just paste that right in and make the changes. So wherever it references the range, H50 to N50, we'll put in the argument headers, and it should be in two places. And next, and the argument description for head is as simple as the header range. And an example might be A1 through G1. Anything you want. All right, so let's give it a whirl. So let's say equals query offset, and we will pass it H50 through N50. And we get the same number. Great. I would hope so. But that formula is pretty complex, whereas this is a bit easier on the eyes, so to speak. Alrighty, so now what we need to do is we have to add this call to the query offset into two of our existing name functions. The first one will be the query name helper. So let's go ahead and update that. So we go to data, and then name functions and query name helper. And we choose edit. That takes a argument that we called range before. So we will just paste that right in here, so that now where we use the column function, we basically added a subtraction with a call to the query offset function that we just wrote with the argument called range. Oops, what did I get wrong? Columns. Thought I got it right. Let's try this again. I'm just going to cancel and start over, and query name helper and edit, and then right over here is where we want to make a call to the new one that we just created with the argument, same argument called range. So columns, and then right here we want to do a -1, not a -1, a minus query offset of the range, and that took that. Okay, I will say editing named functions in that little box leaves a bit to be desired. That was on one of my lists that I included on ways that Google could improve name functions. It'd be kind of nice to be able to have, just like you were putting in a function in a sheet, where it could kind of give you the helper and show you the the templates and help functions to make it easier than trying to do that. It's kind of error prone, as you can see. All right, so now we need to update the query name helper function with the not the query name, the query by name function by adding the same call in this case to where it says column here. We're going to subtract minus the offset in 2 places. So I get it right. I'm just going to paste in the entire formula and keep my fingers crossed. There's the query offset. There's the column minus query offset in 2 places. And if I got it right, it'll take it and we'll choose update. And look at that. Now the error goes away and we get the data that we expected. So voila. Now our query by name function works no matter what column the table starts in. Well, I hope you enjoyed this video, and hopefully you'll be able to use the query by name function. When you pull that in, if you import this into your own projects, it's going to automatically know it requires 2 other name functions. It will request or suggest that you also import the query name helper and query offset. So hopefully feel free to write any comments or suggestions or any of your thoughts down below, and I hope that everything this will be helpful for you in your future projects, and thank you very much. So have a great rest of your day.